Little known fact, the process of converting decimal to binary was actually created by a non-technologist, a brick manufacturer. His name's Rico. What? You haven't heard of Rico? I'm shocked. Rico is a brilliant inventor who created an indestructible, lightweight, low-cost construction brick. You know how construction bricks are. They're like that concrete. They're heavy. They smash on the floor. And so he came up with this new invention, and masses of people lined up behind it to purchase said brick. Now, Rico was a brilliant inventor, but not much of a businessman. His idea of creating a scalable business was to make a big pile of bricks and to hire a college graduate named Mike to be his brick runner. So this guy would come up front and say, I need 210 bricks. And Rico would yell to the back, hey, Mike, 210. And Mike would run back and forth, one brick at a time, bringing 210 bricks to the front. Now you can tell this guy, his smile definitely not as big as this guy, because he's like, oh man, I got to wait for 210 bricks, and then I've got my 100. This is going to take forever. And then this guy, I know you can't tell, but he's kind of like the Joker. Like if you saw the other side of his face, it's just like, sad face, angry, teeth barred, everything like that, because he just wants 15 bricks and he has to wait for these guys that are sitting in front of him. So, 50 bricks into this process, Mike collapses on the floor in the back. Rico's like, oh no. And, it's got like, at the mall, those little gates that go, it's like ching, 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 and it drops down. Other people, hey, I want more. And he's like, Mike, what's wrong? And Mike's like, can't go on like this. We need another plan. We need pallets of bricks. And Rico said, well, what do you mean, Mike? And Mike went to a drawing board, which happened to be nearby, and said, last time I was at Home Depot, I saw these things called pallets. They're made of wood. And so on this pallet, I would propose that we would make a pile of 128 of your brilliantly invented bricks there, Rico. And then next to that, we would create a pallet of 64 bricks. Next to that would be a pallet of 32 bricks, followed by a pallet of 16 bricks, then a pallet of 8 bricks. Yep, you count those. Accurate. 8 bricks. They're just not the same size. Then a pallet of 4 bricks. Rico, seeing where this is going, he's like, okay, and the next one would be a pallet of 2 bricks. And Mike said, no, you don't need a pallet for that. Just a pile, and then we'll have our single miscellaneous brick pile. And Rico, you're the boss, so I'm going to give you a set of flags. And when a customer comes and gives you their order of bricks, you just go and put the flags in the brick piles that I should get, and I will get my pallet lifter, the little tung, 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 and then I will take the pallets up to the front, and the customers will be much happier. Rico thought this was a pretty fantastic idea. So we went back to the storefront, and thankfully the customers were still there because they were really excited about his new bricks. So he decided to test it on the first one. Okay, 210 bricks. He grabbed a little scratch pad and jotted that down. And he thought, okay, I'll put a flag in the 128. Do a quick subtraction problem there. 0, 2, 1, 8, and I have 82 bricks left. 64. Okay, subtract that out. 8, 7, that'd be 18 left over. No 32s, definitely. A 16 brick pile, that'll do you. So subtract that out. We got 2 bricks left. So no, and yes, we've got our flag in the right place. It's not bonus brick day either, so we don't get that little extra brick there. We subtract 2 out, and we've zeroed out the request. Mike, with his little palette, now knows exactly... This is my palette. It now knows exactly which piles to get and deliver up to the front. Now, I know you might be thinking, what does this have to do with decimal to binary? Oh, my friend, you've learned it just now. See, when computers look at numbers, they see it in powers of 2. Meaning, when you and I see the number 210, a computer will actually see 11010010. We've converted to binary. Essentially, where you see the flags represents the ons, and the ons mean that it takes into account or adds that power of 2. See, powers of 2 is something you learned way back in algebra. You probably just didn't have any significance for it back then, so we immediately forgot it, right? 1 is actually 2 to the power of 0. Now, that's not times 0. 2 times 0, anything times 0 is actually 0. I'm saying to the power of 0. Anything to the power of 0 is actually 1. When you go to 2 to the power of 1, that essentially means 1, 2. When you go to 2 to the power of 2, that's 2 2s, or 2 times 2. 2 to the power of 3 is 2 times 2 times 2, and that gives you 8. And this goes on and on and on. This goes 2 to the power of 4, 5, 6, and 7. This is actually where we get our 8-bit numbers. And this is also why when we look at an IP address and we see it's 4 octets and people say, oh, that's a 32-bit address or a 4-byte address. The reason the number can only go from 0 to 255 is because if you add all these up, if you were to turn every flag over to 1 and add them all up, what do you think the biggest number you could get would be? You've got it. 255, right? That's why we can't go above it, is because we're essentially violating the rules of binary when we do that. So let's go back to our next polite individual that's staying in line right there. We've got the request for 210 satisfied. Mike is driving those out to the car right now. This guy is screaming, I want 120 bricks. So where's Rico put the flags? Let's start from a blank slate because I want to make sure you know how to generate those numbers if you forget them. Just start by 1 and start multiplying by 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And just keep going all the way up till you get to 128. That's our 8 bits. And if you want to use flags, you can. But when it comes to computers and thinking like a computer, remember, a computer only has zeros and ones, ons and off. And by the way, that's when I said back in the introduction that this really gives you how computers think. It really is that simple, is just on and offs, a whole bunch of them that combine together to create what we see as our complex programs. That's all there is to a computer. I'm grossly oversimplifying computers right now, but that's it. We're just talking about how they combine things together to make numbers, right? So what was the number again? That's right, 120. So you start from 120 and then just start working your way down. Now, if it helps to put zeros in there, that's totally fine. That's what I do. So I would say, I can't take 128 from 120. That'd give me a negative number. So 0 there. Okay, 64, I can subtract that. So we'll subtract that out. 2, 1, 6, 1, 0. That'd be 11. So 5, 56. Okay, 32, I can take 32 away from that without going negative. So that's 4 and 2. So 4 minus 6, that'd be 1, that'd be 8 left over. So we have our last one, right there, 8, that is 0. So the rest of it is 0, 0, 0. So the binary equivalent of 120 is 0, 1, 1, 1, 1, 0, 0, 0. Yeah? I know right now we're just looking at the skill of converting from decimal to binary because this is going to be an essential skill that we use when you get to subnetting, and I want you to keep it like an arrow in your quiver, right? I know right now you're like, okay, I get it. We're going to do one more. The angry Joker face guy at the very end. We're going to do one more, but I just want you to make sure that you're parking in your head. This is a skill I will need when we get to subnetting, because you will. So we'll get to the angry guy pretending to be happy. He just wants 15 bricks. Ah, the humanity. 128, 64, 32, 16, 8, 4, 2, 1. 15 bricks. No, 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 yes. Minus 8, you can subtract that out. That'd be 7. And we know all those. 1, 1, 1 told together is our 7. So this in binary is 0, 0, 0, 0, 1, 1, 1, 1. Sweet. Now, one more thing. Now, by the way, the rest of this skill is just going to be practice. We're going to practice going from decimal to binary, but I want to ask you, how do you think you'd go back? I mean, look back at that binary number with me. If you were given this, how would you figure out the decimal? Well, using the powers of 2, we just plug in the numbers, right? We know that this in decimal is a 1, this is a 2, this is a 4, this is an 8. We're just looking at the chart up here. So if we were going backwards, instead of subtracting, we just add them all up. 8 plus 4 plus 2 plus 1 gives us our 15. Feeling pretty good? Good. Like I said, the rest of the skill is going to be practice. For now, you have walked through the process of converting from decimal to binary to prepare for IP version 4 subnetting. I hope this has been informative for you, and I'd like to thank you for viewing.